Hi everyone, welcome back. Today we're doing valid parenthesis. We're given a string s, and this s contains just the characters, round brackets, curly brackets, and square brackets, and we have to determine if the input string is valid. In this case, an input string is valid if open brackets are closed by the same type of brackets, and open brackets must be closed in the correct order. So for example, in this case, this round bracket is closed accordingly by the round bracket over here. So this is a valid input. In this case, for the second, the round bracket is closed by its corresponding closing round bracket. Same for the square brackets and same for the curly brackets. So in this case, we output true. And for the third example, we have a round bracket, but it is closed by the incorrect bracket, which is a square bracket. So in this case, we return false. And in this case, for the whole string given to us, this length is from 1 to 10 to the power of 4, and s consists of only these types of parentheses. So to solve this question, we can use a stack to keep track of what brackets are we encountering. And the idea is that if we encounter an opening bracket, we will append it into the stack. And if it is a closing bracket, then we will try to pop the top of the stack and match that with its corresponding closing bracket. And if it is true, then everything continues. But if it is false, we will break the search and we will return false. So that's pretty much the essence of the approach. So that's all words. So once again, we will have the same habit of using a single test case to test out this approach. So the first thing is to initialize our stack. So let's call this parenthesis stack. Let's call this open parenthesis stack for better readability. And in this case, let's use a list as a stack. And we can use a list as a stack by appending items to the right. And if we wish to pop something, we just call .pop on the list and that will pop the item on the right. So that's pretty much it. So next, we will also define isValid. And this will be a boolean. Let's set this to true. So it will be valid until proven false. And the next thing that we will do is to define two sets. These two sets would just be used for convenience. So you could use if-else statements to check whether if the parentheses are like this, but I personally prefer to just define open parenthesis and just put all the valid open parentheses into a set. And I would just proceed to put in the round brackets, the square brackets, as well as the curly brackets as the opening parentheses. And in this case, that's pretty much it. So let's get started. The next thing we will do is first do a linear iteration across S from left to right for character in S. And the first thing we will check is if character is in open parentheses. Then what we will do is we will append it into the open parenthesis stack. And that's pretty much it. Else, in this case, if the character is actually a closing parenthesis instead, then if character is equals to, let's say square, sorry, this closing parenthesis square, then what we will do is we will set the current character to be equals to, let's call this the current open parenthesis. So this would be open parenthesis stack dot pop. So in this case, this will be assigned to the closest parenthesis we see thus far. So in this case, we will compare if current open parenthesis is not equals to the opening parenthesis, then we will set isValid equals to false and we will break this cycle. Then similarly in this case, else if current open parenthesis is, oh sorry, this is pretty much fine. So this is okay. I think it's good. So now we will be doing the same for the other two types of closing parentheses. So if this is a closing round bracket like this, then similarly current open parenthesis let's just copy this so that we don't make any mistakes. So open parenthesis stack.pop, and similarly, if the current open parenthesis is not equals to the corresponding opening round bracket, then in this case is valid is false, and we will break as well. And finally, this is for the character which is the curly bracket. So if it is a closing curly bracket, then similarly current open parenthesis is equals to open parenthesis stack.pop, and if current open parenthesis is not equals to the opening curly brace, then is valid will be equals to false, and we will break as well. So one thing that I noticed as I was tracing is that I could have abstracted this out if I did an else and put all of this under this branch over here, and I can abstract out the logic of getting the current open parenthesis under this else block. So this would save a lot of lines, and this will be easier for tracing in a bit as well. So let's remove all of the duplicate logic of getting the current open parenthesis, and in this case we would just do this. If character equals to this, if break is this. Okay, so we can see some nested logic over here, so we can concatenate them instead. So yep, that's pretty much it. And this is pretty much the logic for this strategy. That's pretty much it. And at this point, of course, at the end, we will return is valid. So now that we have a strategy, let's quickly test this out with an example, just to be sure that we didn't encounter any errors. So in this case, this is our current test case, and the expected answer is true. So let's get started. We will first start on line 7, and open parenthesis stack is currently equals to an empty list. Is valid is currently true, and open parenthesis is already defined. So in this case, this will just be a set that contains all of the opening characters like this. Opening parenthesis, sorry. And now let's start iterating all characters in S. So now the first character would be this opening round bracket over here. So now since character is in open parenthesis, we will append it to the stack over here. So this stack will currently contain this round bracket. Now we will move on into the second iteration. This is a closing bracket. And since this is not in, this will be false. Since this is a closing bracket, we will hit this branch over here. So current open parenthesis will be set to this round bracket over here. Let's bring it down for readability, and we'll be popping this off the stack. And now we are checking, we will be hitting this branch. So currently this would be true. So this is currently true. This is actually false. So we don't have to evaluate this. And in this case, this is true, and current open parentheses is indeed equals to the correct opening parenthesis. So in this case, this is not true, so this is true and false. So this continues, is valid is still true, and we continue with the next item. So now we'll be pointing at the square bracket. Character is now assigned to this square bracket over here. And in this case, this is open in this square bracket is an open parenthesis, so we will append this into the stack as usual. So that's pretty much it for this iteration. Now we encounter this closing square bracket. In this case, we will hit this branch over here. So over here, the current open parenthesis is indeed, current open parenthesis will be equals to the square bracket over here. So in this case, this is true and false. So this will be overall false as well. And we will pop this off the stack. And we are done with this iteration as well. We will set this to the curly bracket at index 0, 1, 2, 3, 4, index 4. And now this is a open parenthesis, so we will append this into the stack as usual. So this is right. And we are pretty much done with this iteration. Now let's set this to the final character, the closing bracket. So in this case, we will skip this because this character is a closing parenthesis, not an open one. And the current open parenthesis will be set. The current open parenthesis will be set to the first item in the stack, and we will pop it off. So in this case, this is the curly brace over here. So we will hit line 24, and in this case, actually, just to be sure, we should do a check for curly brace here as well. So in this case, character is indeed equals to this closing curly brace. So this is true. And the second expression is current open parenthesis not equals to open curly brace. But this is an open curly brace, so this is false. So we don't hit this as well. And our open parenthesis stack is empty, and isValid is now true. So that is something that this test case doesn't really test for, is that it is possible for us to have a non-empty stack. Right? So we can also do isValid and length of open parenthesis stack to be equals to 0. So if the open parenthesis stack is not empty, it means that there are still some parentheses that are not closed. So let's try a harder example. Let's try this example over here. So this simple example, actually, it can be a very simple one like this. So in this case, we will reinitialize this to an empty stack. isValid will be reset to true. Open parenthesis is initialized to this as usual. And now let's set this to an open curly brace. So in this case, this is an open parenthesis, so we'll append this into the stack. And at this point, we are done. And in this case, isValid will still be true, but we know that the expected answer is actually false. Like this is expected to be false because there is no closing parenthesis. And because we added this additional check over here, now this would be evaluated as true and false. Because the length of open parenthesis stack will be 1 over here. So this is a good check. Let's see. Let's try it with one more test case. This opening brace and this closing bracket over here. This squarish closing bracket over here. We will reinitialize the stack to be an empty stack. We will reset isValid to true. Open parenthesis is defined as usual. And let's start iterating the first character. So in this case, we are checking if the opening round bracket is open in open parenthesis, and that's true. This will be evaluated to true. So we will append this into open parenthesis stack. And we will continue with the next item, which is this square bracket over here. So I'll remove all of the old workings so that it's not confusing. So currently, this is this square bracket over here. So we will hit this branch. So this branch, character is indeed equals to the closing square bracket. So the first expression is true. And the current open parenthesis over here would be set to this round bracket inside the stack. So this one over here. So in this case, the current open parenthesis is indeed not equals to this correct opening square bracket. So isValid will be set to false. And we will break this search, and this will evaluate to false and true, which is false. So we get the expected answer false. Looks great. This strategy seems like it will work well. So let's try implementing this. We already did as we traced, but let's just go through the whole algorithm again. The first thing that we did was that we defined an open parenthesis stack. And this stack is used by us to ensure that all opening brackets are so that we can use this stack to get the closest opening bracket to be closed. So over here, we define this stack and this initialize as empty. We define an isValid boolean to indicate whether if S is valid, and we initialize that to be true until proven false. Then just for convenience, we define an open parenthesis of a set of all opening characters. If you do not wish to use a set, that is totally fine, but you'll be dabbling with some if-else statements. Well, under interview conditions, I think it's nice to have these little tricks to make life a little easier. So for character in S, we start to do a linear scan across S, and what we're doing is we're checking if the current character happens to be an open parenthesis. So if the character happens to be in open parenthesis, then what we will do is append each of these characters into the character. Else, if this character happens to be a closing parenthesis, then what we will do is we will currently pop the closest current open parenthesis from the stack like this. And once we are done, we'll proceed to check for a couple of cases where we will terminate the check. So in this case, if character is equals to a closing square bracket, then we will also check if this current open parenthesis happens to not be the right closing bracket, which is the square bracket. So if that's the case, then isValid is equals to false, and we break this. Else if, similarly, if the character that this closing bracket that we're looking at is a round bracket, and the current open parenthesis is not equals to the corresponding opening round bracket, then similarly, this string S is not valid, and we will break the cycle. And finally, if the character is equals to a closing curly brace, and the current open parenthesis is not its corresponding opening curly brace, so in this case not equals to opening curly brace, then isValid is false, and we will break as well. And finally, we will return isValid along with an additional check on the stack. So if the stack is not equals to 0, then it means that some brackets are not closed properly. So looks like everything is fine. So let's quickly look through the implementation again. Stack is a list. We use a list as a stack. isValid is true. Open parenthesis contains the right opening three characters for open parenthesis. We do a linear scan from left to right in S. We check if character is an open parenthesis, and if it is, we append it into the stack. Else we pop it. If it is an closing parenthesis, then we pop the closest open parenthesis that we've encountered thus far. And what we do is we check whether if it's one of these closing parentheses, and if they should be closed with the correct open parenthesis. So looks like everything is fine. Let's run this against the test case. This is accepted. Let's run this. Pop from empty list. Okay, another test case to which I missed out is that you might encounter closing parentheses without encountering any open parentheses. In other words, you might pop from an open stack. Okay, so in this case, you can see that I actually messed it up and I missed out some test cases over here. And to be specific, the test case is if you have S equals to, let's say, this. So in this case, we must make it a point to also, okay, so let's see, open parenthesis stack pop. By any chance, does pop have a default? Python pop. Default. No, pop does not have a... Seems like pop does not have a... Seems like pop does not have a default. So what we will do is we will try catch. We can define this as under a try catch over here. And if this pop fails, what we can do is we can just return false. So this looks great. Yep, this looks good. So if we encounter a closing bracket like this, and it encounters an error, in other words, an index error, then we will just return false over here. So let's run this. And this gets accepted. Looks great. So in this case, the time complexity, if we take a look, we are iterating through all characters in S. So if we let n to be the length of S, then in this case, the time complexity would be O(n). And currently we are, this check for character in open parentheses will be O1 because we use a set. And all of these operations at the bottom are just if-else statements, so that is constant time. So time complexity in this case will be O(n). And for the space complexity, we use an open parenthesis stack to keep track of open brackets. So in the worst case, if S consists of only open brackets, then this open parenthesis here will contain as, sorry, not this one over here, but this open parenthesis stack over here will contain as many elements as S. So in this case, this open parenthesis stack on line 13 is going to take up the O(n) space. So that looks great. That's pretty much it. And that's it for this question, valid parenthesis. If you like this, please give us a like and subscribe, and we will see you in the next video.